Hello, my name is Christopher Hanusa, and I'd like to welcome you to Math 120, Discrete Mathematics for Computer Science. Let's take a few minutes to talk about what we'll be seeing in this course. What is discrete mathematics? The word discrete means consisting of distinct or individual parts. And we often think of discrete mathematics in contrast to continuous mathematics. If we're thinking about something that is continuous, we may think about an entire spectrum of colors. Looking at a rainbow, you can pick out any color along the way. While the discrete version would be a set consisting of three colors: red, yellow, and blue. They're distinct, they're individual, it's not part of a spectrum. Another example is the interval, 0, 1. Every single number and its decimal representation between 0 and 1 are in that interval. Whereas if we take the set 0, 1/4, 1/2, 3/4, and 1, those are 5 discrete points. We can also compare the real numbers, the whole number line, to the set of integers, where it's only every whole number. Up until now, you've probably been dealing with continuous functions, functions that have a domain of the real numbers, a codomain of the real numbers, and you can draw a graph to represent the points on that function. Discrete functions behave differently. You've got a set of objects for the domain, a set of objects for the codomain, and there's some rule about which input maps where. This whole course will be talking about discrete objects. In this course, we'll be talking about 5 different types of topics. Sets, or collections of objects. These are the building blocks of discrete math. Then we'll talk about combinatorics, which are counting techniques. Once we have a collection of objects, we'd like to know how to find the size of that set. After combinatorics, we'll be talking about functions. We'll be talking about rules that describe relationships between sets. Given an input, what rule is going to give you the output? Next, we'll be focusing on some computer science-specific algebra that you need to know. We'll be talking about exponents and logarithms and sequences and series and products and how all those things relate to each other. At the very end of the course, we'll be talking about some basic number theory involving divisibility and modular arithmetic. So that's what we're going to be learning. Let's talk about how we're going to be learning it. You're probably used to a course structure in which you go to class, you take notes while the instructor lectures, and then when you go home, you try to make sense of the notes by yourself, working alone to understand the material and complete the homework. This class will run differently. We've produced some video lessons for you to watch before class. You should watch them, take notes, and answer a few related questions to prepare yourself for class. In class, there'll be a quick recap of those key ideas from the video lessons, which gives you an opportunity to ask questions about what you've watched. Then class will transition to group work. You'll be working with classmates on activities so that you can develop some confidence with the material. Then after class, you will have a chance to practice the concepts with some homework assignments and online interaction through the course discussion board. Why did we decide to organize the class like this? It comes down to a question of how much time there is that we have together. We would rather use our class time for higher level thinking activities so that when you have questions about something that's complex, you have your peers around and your instructor around. Our goal is to form a learning community so that everyone can get the most out of discrete mathematics. We want you to be fluent in these ideas so that you'll be able to use them when you go on to your next computer science class. There's a few more things I'd like to bring up in relationship to this class. First, we are aiming for transparency in expectations. The entire course content is centered around a set of learning objectives, which gives you a roadmap for what you need to learn to do well on assessments. We've created a set of curated resources. Every day's content is accessible on our course webpage, and this webpage has background reading from the textbook and external resources. It has the video lectures that have been broken down into digestible chunks and available to watch and rewatch as necessary. And there are also links to additional videos in case you want to think about the content from a different point of view. And we're all in this together. There's help. Use the course discussion board to contribute to and access the knowledge in your learning community of your peers, of your instructor. You can ask your instructor questions during office hours and in class. You can visit the Math Help Room in Kylie 331. That's a place where you can drop in and ask questions. Or if you prefer, you can schedule a group or solo tutoring session at the Learning Commons. We want you to learn the material. We want you to succeed in this class. And our final message to you is that you've got this. We wish you good luck and all the best in discrete mathematics.